Hello everyone, welcome to thermodynamic lectures. In this lecture we will discuss about energy balance on closed system. Energy balance on closed system. So the general energy balance equation, we will write first of all the general energy balance, which is nothing but energy in minus energy out. Energy into the system, energy out from the system, energy generated within the system due to chemical reaction minus energy consumed in the system due to some chemical reaction is equal to energy accumulation. So this is the general equation of, or this is the general energy balance equation. So this is energy in, energy out, energy generated in the system, energy consumed in the system, energy accumulated in the system. Now let us consider a closed system. Let us consider a closed system like piston cylinder assembly. Closed system. This is a closed system. There is some mass present or some mole or some mass of same molecule. So it can be oxygen or carbon dioxide or some other gas. And this is the piston, frictionless piston. Piston, frictionless piston. This is the cylinder. And this is the piston. If we give some heat to the piston, if we give some heat to the system, which is delta Q, and if we apply some force on the system, like in this direction, or if we apply some work on the system, which is delta W. So what will be the internal energy of the system from the energy balance equation, from this equation? So suppose this is equation number 1. So this is the closed system. This one is the closed system. We will write the energy balance for this closed system. So energy enter to the system. Yes, heat is entering, which is energy. Heat enter to the system is taken as positive. Heat leaving the system is taken as negative. So it is plus Q. So one energy is heat, which is entering to the system, Q. So the other is the work done on the system. Surrounding do some work on the system to compress the system. So compressional work is denoted as negative minus delta W. So work done by surrounding on the system will taken as negative. So work is minus delta W. These are the entering. So one is the energy enter to the system is this, one is this energy. So now energy out from the system. If this is a diabatic system, if this closed system is adiabatic, if there is no heat enter or no heat out, so suppose this heat is only entering through this side, through this base, either by conduction or radiation, and heat is not flowing out through this side, this vertical side. So heat out will be 0. So heat out will be, no heat is released from the system, only heat is entering to the system. So this is a simple system. There is no chemical reaction in this system. So there is no chemical reaction in the system. If a reaction taking place in a system, then the generation and consumption, energy generation, energy consumption term will be appear. But this is a simple case. There is no energy generation or no energy consumption, so this cancel. This is energy accumulation. So yes, energy accumulated. Yes, energy accumulated. Energy increases in the system in the form of internal energy. So energy accumulation is nothing but change in internal energy. So this is the energy balance equation on a closed system, and this equation 2 is called the first law of thermodynamics. This can also be written as that the heat which we supply to the system, that converted into 2 energy. One is some of the heat converted to the internal energy to increase the internal energy of the molecule or atoms or ions, and the rest of heat energy will do some work. So the heat energy which we enter to the system is converted into the internal energy of the system, and due to this heat, the internal energy of this system increase, and similarly due to this heat delta Q, the system do some work on the surroundings. So this is plus delta W. So this is also called the first law of thermodynamics, and this is the energy balance equation on a closed system. So this was about the closed system, and in closed system the other energy terms like kinetic potential energy terms are usually neglected. These are very small, so we neglected these energy terms. Now this is the energy balance equation on the closed system. Now the energy balance equation on rate base high energy. So on the basis of rate basis, energy rate enter to the system, energy rate out from the system, and energy plus energy generation minus energy consumption is equal to energy accumulated. So change in energy in the control, in the change in energy in the closed system, change in energy in the closed system per unit time. So this is the energy accumulation on rate basis. So if no energy is outing, suppose this is a system, piston cylinder assembly, these are some gas molecule. If we give some heat to the system delta, and we apply some work on the system, and if the wall of the and if this wall, if heat can flow through this wall, so heat is releasing from the system, we will take its minus Q. Suppose the heat is releasing from the system to the surrounding, so we give some heat to the system, but when we apply work on the system, some of the heat will release from the system to the surrounding, and some of the internal energy also increases of the system. So how the energy enter? The energy entry is from delta Q, and this is the energy enter. So delta Q and the work if you done on the system, and this is the energy entry, this is energy enter minus energy out, this is minus delta Q. So minus delta Q. Energy generation and consumption, there is no chemical reaction like this taking place. A is consumed and B is generated in this reaction. A is consumed and B is generated. There is no chemical reaction in this system. So this is, and these two terms are cancelled, and the energy change of the system, energy accumulated in the system. So some of the energy accumulated or changes or energy changes of the system is nothing but the change in the internal energy of the system. So it is the internal energy of the change in internal energy of the system with the passage of time. So this Q is the work, this delta W is the work done on the system or compressive work. So it will be taken as negative delta QO minus delta W minus delta Q is equal to T by dt. This delta Q is the heat release, and this is the heat enter to the system, this one. So it can also be written as heat equal to work, heat release, and internal energy increase. So on the rate basis there will be dot on all the symbol. We will put some dot on the rate base method. So this is the rate balance equation on the closed system. Or for the simple closed system, if the heat is not releasing to the environment, suppose this Q is 0, there is a adiabatic system, only this is so only heat is transferred through the base of the system, and this delta, this will be 0, this will be also equal to 0. So only this relation will become delta Q is delta W. This is minus. This will be minus for the this will be the minus sign, minus delta W, because work is done on the system, and this will be equal to the internal energy, change in internal energy of the system. So change in internal energy for unit time, or it can also be written as, so this is will be the energy balance for the closed system in rate based method. So this was all about the closed system. Thank you very much.